The first two terms of an arithmetic sequence are 4 and 12. What are the next two terms of the sequence? The common difference is 8. So to get the next two terms, you simply add 8 to the previous term. So 12 plus 8 is 20, and 20 plus 8 is 28. The first two terms of a geometric sequence are 4 and 12. What are the next two terms of the sequence? The common ratio is 12 divided by 4, or 3. So to get the next two terms, simply multiply the previous terms by 3. So the next two terms are 12 times 3, which is 36, and 36 times 3, which is 108. The first two terms of a Fibonacci sequence are 4 and 12. What are the next two terms of the sequence? To get the third term, you add the 4 and the 12 to get 16. And then to get the fourth term, add the 12 and the 16 to get 28. Write an nth term formula for the sequence. Since this is an arithmetic sequence, we can use our formula for arithmetic sequences. The first term is 6 and the common difference is 7. If you want to simplify the formula, it would simplify to a sub n equals 7n minus 1. For that same sequence, what's the value of a sub 7? The common difference is 7, so the easiest way to find a sub 7 is to just keep adding 7 to the terms until we reach the 7th term, which is 48. You could also use that nth term formula that you just found. How many terms are in the sequence? Well, since we have this nth term formula that describes the sequence, we can use the nth term formula to find the number of terms. 363 is equal to 7 times the number of terms minus 1, which means the number of terms is 52. Write an nth term formula for this sequence. This is a geometric sequence that has a first term of 4 and a common ratio of 3. So an nth term formula is a sub n equals 4 times 3 raised to the n minus 1 power. How many subsets does the set ABC have? Since the set has 3 elements, it has 2 to the third, or 8 subsets. List the subsets of the set. The 8 subsets are contained in this list of subsets. Don't forget about the empty set as being a subset. How many proper subsets does the set have? Remember that the set ABC has 8 subsets, but the subset that is equal to ABC is not considered a proper subset, so we have to subtract that one subset off of the total number of subsets to get the number of proper subsets. So 2 to the third minus 1 is 8 minus 1, or 7 proper subsets. For these sets, we have a universal set and 4 other sets. Answer the true or false question. So the question is B a subset of C? And that is true because every element of B is also contained in C. For that same list of sets, answer true or false for this question. So the question is D a subset of B? And the answer is true because the empty set is a subset of every set. And for the same list of sets, answer this question. The answer is false. A is not equal to C because the elements of the two sets are not exactly the same. And for the same list of sets, answer this question. In this case, the answer is true. A is equivalent to C because the two sets have the same number of elements. For the same list of sets, answer this question. This one is true. A complement is equal to C because C contains all the elements of the universal set which are not in set A. Now we're using the same list of elements, but now we're being asked a question about one-to-one correspondence. Two sets are in one-to-one correspondence if the elements of the two sets can be paired with each other with no elements left over. So which of the sets can be placed in a one-to-one correspondence with the set frog, toad? Set B can be placed in a one-to-one correspondence with the set frog, toad because the two elements of set B could be paired with the two elements of the set frog, toad, and nothing would be left over. For these sets, answer the question. We're looking for J union M. So J union M contains all the elements of both J and M combined, which would be the elements 1, 2, 3, and 5. For the same list of sets, answer this question. We're looking for N intersect M, which means we want a set containing all of the elements N and M have in common, which would be a set containing 3 and 5. "50 people were asked what type of clothing they had purchased in the last week. So with this information, how many had purchased none of the 3 items? Make sure you make a Venn diagram containing all the information and use your Venn diagram to answer the question. The answer is 11. For the same information, how many people had purchased only pants? 8 people had purchased only pants. For the same information, how many had purchased shoes and a shirt, but not pants? Six people had purchased shoes and a shirt, but not pants. Look at this Venn diagram and look at the shaded part. Which of the following describes the shaded region? There might be more than one answer, so look carefully at all of the answers. These two are correct. They both describe the shaded region. Use Gauss's method to find the sum. So for Gauss's method, we need to know the number of terms, the number of numbers we're adding, which is 88. That would give us 44 pairs of numbers. Each pair would add to 89. So for the sum of all these numbers, we take the number of pairs times the sum of each pair. 44 times 89 is 3,916. Frank makes custom bicycles and tricycles to sell in his cycle shop. He has 12 seats and 32 wheels in his inventory. How many bicycles and tricycles can he make if he wants to use all of the seats and all of the wheels? He can make 8 tricycles and 4 bicycles. Janice wanted to feed her 2 dogs some doggy treats. She gave her Dalmatian 3/8 of the treats, and she gave her poodle 3/16 of the treats. Then she counted the leftover treats and found that she still had 14 treats left. How many treats were in the bag to begin with? There were 32 treats in the bag to begin with. How many treats did she give her poodle? She gave her poodle 6 treats. How many treats did she give her Dalmatian? She gave her Dalmatian 12 treats.